In our seventh podcast for chapter 21, we're going to start by introducing what happens when we have voltages that are not at standard conditions. And what I mean by introducing that is we're going to see then, all right, once we start with our standard conditions, right, we are going to have a spontaneous reaction, usually one way or the other, depending on what the voltage is, right? And so we can look at that and we're going to see which direction our reaction is going to go, and that's going to help us figure out, okay, then what happens when we're not at standard conditions overall. Then in podcast number 8, we're going to actually calculate the voltages at non-standard conditions as well. We know from looking at the thermodynamics chapter that there is some sort of an effect on the concentration, so there's some sort of effect on Gibbs free energy change whenever we change the concentrations of stuff. Well, we know that if we're going to change our Gibbs free energy, then that also is going to affect our standard voltages because they're tied together, right? Our delta G naught is equal to negative NF E naught, right? They're tied together, so if I change one of them, I've got to change the other one. They're actually directly related to each other because they're on opposite sides of an equal sign. So we know that the voltage of something is going to increase if we increase the concentration of a reactant. And the voltage is going to increase if we decrease the concentration of a product. So think about this along the lines of Le Chatelier's principle. The voltage of something is going to increase if we drive our reaction towards our products. And remember that that happens by Le Chatelier's principle when we increase the concentration of reactants or decrease the concentration of products. So again, Le Chatelier's principle hasn't gone away. It's like many things in Chem 2, right? They seem like these vastly different topics from time to time, but yet we use the same principles almost time and time again. So the opposite of that is that the voltage will decrease if the concentration of reactant is decreased or the concentration of product is increased. Again, this is Le Chatelier's principle in effect. You know, all we're doing is saying, okay, our voltage increases if we drive our reaction to our products. Our voltage must decrease if we drive our reaction towards our reactants, which happens when I decrease the amount of reactants or I increase the amount of our products. If we think about a voltaic cell, right, our voltaic cell is going from our reactants to our products, right, the way that our equation is written. So as the reaction takes place, the amount or concentration of our reactants starts to go down, and the amount or concentration of our products is going to start to go up. Well, we know as the amount of reactants decreases and the amount of products increases, right, then our reaction is going to start to slow down, and eventually we're going to reach a point where we reach equilibrium, where we have the same rate of reaction going in the forward direction as the reverse direction. And so when the forward and reverse are at equilibrium, when they're at the same rate and we're at equilibrium, then nothing is occurring that we can measure. Yes, the reaction's still going forward and still going in reverse, but they're going at the same rate, and so we don't see any net driving force overall for that reaction to be happening. And so if they're going in both the forward and the reverse reactions at the same rate, then what we're going to find is that the overall voltage at that point is going to be 0 because there's nothing to force the reaction to make products. Like if there was a spontaneous reaction, there's nothing that would drive the reaction to go back to reactants if it were the opposite of a spontaneous or a non-spontaneous reaction. So in between those two, we're going to have a voltage of 0. All right, so that was a shorter podcast. The next podcast is going to be doing calculations when we are not at standard conditions and how that affects things by using what we're going to call the Nernst equation to calculate non-standard values. So that'll be podcast 8.